For this video, this is for Mod 2 Lesson 3, which is solving logarithmic equations. As we talked about in the previous video, logs are the inverse for exponential equations. So we're first going to start talking about how do we solve an equation that has a log, because that ends up being a little bit easier than an exponential equation. So our goal today is just looking at how do we solve equations that have logs in it. So these are the steps we're going to use. We're going to isolate the log, evaluate both sides base b, solve for x, and the big thing we're going to see is we talk about something called extraneous solutions. So that's a solution that if we come to at the very end, we want to make sure that it satisfies the original equation. So specifically for logs, like if I have the log of, let's say the log of 5 for x, for example, we're going to find that anything we solve for in this problem, we want our x, or whatever's inside our log that's getting evaluated, has to be greater than 0. So if I can't, for example, have a -5 in for x or anything of that nature. So you always want to make sure when you plug it back in, you can't have a negative value inside those parentheses. Otherwise, you're going to get no solution. In example 1, we're looking at solving log equations. So the big thing we're going to see here is if I have a log, the inverse of that is raising it to that base. So for example, for number 1, this is actually a base 10. So if I rewrite this, I always like to leave a little bit of a space because I know I'm going to end up putting something kind of by that too. We're going to raise each side to base 10 because it's a log base 10. So what happens is that cancels out the log. We're left with x minus 4. On the right-hand side now we have 10 squared, which is 100. And now we're left with just a linear equation. So we have here x minus 4 equals 100. When we go ahead and solve, we're going to get 104. For the question number 2, it's basically the same thing. So the first step is, again, we isolate our log. So I have a 2 that's multiplying it out front. So this is my log. I'm going to get it by itself. And so I'm going to go ahead and divide both sides by 2. I have log base 3 of 5x is equal, I'm going to leave a little space, equal to 4. And then now I'm going to raise both of these to base 3, right? Because if this is log base 3, that inverse would be base 3. This cancels out. I'm left with 5x equals 3 to the 4th, and 3 to the 4th is 81. And then finally, now I'm left with a linear equation. I'm going to divide by 5. And this would be a 16.2. For the next problem, same thing. This just happens to be a natural log. So remember, that's really the same as saying log of base e, right? Those are the same thing. And you wouldn't necessarily have to write this part. But basically, I have to raise both sides to base e. So I left with 8x equals e to the second. In our calculator, you do second and natural log to get that e. And then I usually like to wait till the very end so we don't have to worry about rounding too much. So I'm going to leave it as e squared just for right now. We're going to divide by 8. And then I have x equals e to the second over 8. And then when I put that in a calculator, that's going to give us our final answer. And I'm going to do 2 decimal places, so 0.92. For the last problem, same thing. I'm going to go ahead and isolate my log first. Parentheses are really helpful so you can kind of see that 1 isn't actually with the log. It's kind of hanging out there. We're going to go ahead and subtract 1. So log base 4, 2x plus 5, equals 2. I'm going to leave a little blank here. And then I'm going to raise them to each to the 4th. Or a base of 4. This cancels out, and we have 2x plus 5 equals 4 squared, which is 16. That's for this right here. And then we're just going to go ahead and solve. So you should get this to be 5.5. The last one, two examples are when you have a log to a log. So these are actually both base 10. You're going to see, though, if I raise both of them to the 10th base, they actually both cancel out. So whenever you have a log equaling another log and they're the same base, you're just going to set them equal. So I have here 5x minus 1 equals 3x plus 5. And again, just make sure, especially when it's log to log, that you're not getting an answer that would make the what's in the parenthesis equal 0, so or a negative number. Otherwise, you'll get something that won't make sense. So if I go ahead and solve this, we get 3, and just to kind of test, and the other ones we could have tested too, but definitely when it's log to log, it kind of pops up a little bit. If I put in 3 in for x, I end up getting log to the 14, which would give me a value that actually would make sense, and that would be my final answer. For the last problem, same thing. If I raise them to the same base, again, log to log, it's just setting those equal. So 2x plus 15 equals x minus 1. If we go ahead and solve, we get negative 16. But when we plug it back in, we get the log of negative 17. Which is actually no solution. So actually our answer here is no solution. We can't have a log evaluating a negative number or evaluating 0. If you have any questions, you can sign up for T-Bolt time, get help in the center, or ask questions during class.